Today is already week 5. And I'm supposed to use Gauss elimination to determine if the system unique, no solution, or infinite. I have finished the one with m equals n with 4 methods. Yeah, that one I have finished. So let's see what happens if m is not n, or even m is equal to n, but there is a row of zeros. Right? Okay. So let's go straight to the 2.6, yeah? 2.6. The existence of solution and consistency. Okay. Okay. The existence of solution, and consistency. Okay. So we have a unique or just one solution. We have seen this before, right? Using Cramer's, using inverse method, using Gauss and Gauss-Jordan, we can also get this. We can also have many solutions or infinitely many solutions. Infinite. Many or infinite. Okay, many or infinite. And we can probably have no solution. I showed you last time, right? The examples at that time is m is n. For these two, we call this system of linear equation to be consistent. If there is a solution which is unique or many solutions, we call it the system of linear equation is consistent. So if the question mentions something like, decide whether the following system is consistent or not, they don't ask you to find the solution. They want to know whether there is a solution or not. Yeah. For this is inconsistent. Okay. Okay. Now the example given there is a system of linear equation . 2 by 2. If you want to write the A, I found one time that the X and Y is switched in the second equation. So you really have to check, saja nak gunakan kan, Y first and then X. So make sure it's X, Y, and so on. So the A here, the first one is 1, -1. This one 1, but there is no Y, so it's 0. So don't get confused with this. And B is 0, 1. Before I forget, this Tuesday, I will give you a quiz, yeah? Quiz 2 for chapter 1 will be determinant and inverse. Right? Okay. Then for this one, you remember to draw the line? All right. You can draw the line X equals Y, right? For this one. This is X minus Y is 0. Or Y is X. And this is X is 1. X is 1 will be this, right? At 1. So you see, there is one unique solution. This is an example how you can show it geometrically. Okay. Second one. The second example is x minus y is 0, 2x minus 2y is 0. Okay. So this gives y is x. This gives y is x, or x minus y is 0. This gives the same thing, right? 2x minus 2y is 0, give x minus y is 0, x is y. So this is also the same thing. So they overlap at the same place. And this means these are all the solution. Everything on the line is a solution, right? So the answer will be many solutions. As long as y is x, right? So 0, 0 can be a solution, 1, 1 can be a solution, 2, 2 can be a solution, or x negative x is solution. So this is infinitely many. Because all this, when they put there, it satisfies both equations. Okay. The third one, x minus y is 0, x minus y is negative 1. How can it be? X minus y is 0, x minus y is negative 1. Even when you add or you minus, right? When you minus this, you will get, right? 0 is 1, which is wrong. Okay, if you draw, okay, x is y, right? X is y, so x minus y is 0. And this is y is x plus 1, right? Y is x plus 1, meaning it goes up, right? At 1. So do you have a solution? Do they intersect? They don't intersect. They are parallel, right? We learned before, if you write in terms of y equals mx plus b or c? C. Okay. The first one is y is x. The second one, y is x plus 1. So we learn if m is the same, right? They have the same m to apa? Slope, right? It has the same slope. So it is parallel. So parallel lines, they don't intersect. So no solution. In that case, no solution. So this is how you show the solution geometrically. If it's 3 by 3, then it's like a plane, right? A plane satah, bukannya kapal terbang. It's a plane, right? It can intersect. If the plane is the x, y, z, ax plus by plus cz equal d, ax plus by plus cz equal d is actually an equation of a plane, right? So if the plane parallel like this, then it don't intersect, right? If the plane is the same plane, like x plus y plus z equals 1, 2x plus 2x, 2y plus 2z equals 2, they are the same plane, so many of them. they can also intersect. If this can go inside, intersect at a line. It can also intersect at a line. So there will be many solutions. Yeah, it can intersect at just a point also, maybe at one point. It can intersect at many, like the whole plane or just a line, or it does not intersect. That is 3 by 3. Okay, now I want to introduce two types of system of linear equation. I will do more, yeah, for this one later, how to write the answer. Two types of system of linear equation. Two types. Two types of system of linear equation. After this, if I mention this, don't ask, I don't know this type of the equation. The first one is called homogeneous. For homogeneous, B is 0. For homogeneous, this is a vector actually, yeah, not the number 0. And the non-homogeneous. AX is B. Okay, for this one, for the homogeneous one, it's always consistent. Because X is 0 is always a solution. It's always a solution. If you have something like this, 2x minus y plus z is 0, x plus y minus 2z is 0. This is like, or called homogeneous, equals 0, equals 0. So when I said this, that means this is always a solution, because when you plug in 0 minus 0 plus 0 is 0, right? 0 plus 0, so 0, 0, 0 is always a solution. So it's always consistent when this is equal to 0. For this one, non-homogeneous, it depends. It has 3 kinds, like before. Okay. So now we want to look at the non-homogeneous first. If you have a question, just raise your hand so I can see that you move up to the first cell, right? To the first page. Yeah. And then kalau saya tak nampak juga, kena bercakap lah. Itu soalan. Okay. Okay is the magic word. What do you have to do? Okay. All right. Okay, now we look at the non-homogeneous. And we have 3 types, right? We have unique, many, or no. So we have 3 types. Okay. So what we will see is the type of solution can be determined using the rank of the coefficient matrix. Okay, the rank, remember from chapter 1, the rank is the number of non-zero rows, okay, of the row echelon or row reduced echelon matrix. Okay, that is the rank. We can determine whether it has a solution or not from the rank of the coefficient matrix. Okay. Okay, that is 2 matrices that I want to mention. This A, X is B. Okay, A is the coefficient matrix. A, B is B, is the augmented matrix. Okay, so we will determine this kind or the type of solution from the augmented matrix. Okay. The rank of this and the rank of this. Okay. If the matrix is square, like before, we can also check the determinant. The determinant, if M is N, suppose A is M by N matrix. If M is N, the determinant is not 0, then you have unique, right? If the determinant is 0, we are not sure whether there's no solution or many solutions. Okay, and we cannot use the, what do you call it? The first two methods, the inverse matrix method or the Kramer's method cannot be used. Okay. Now the first one, we want to determine the type of solution by checking this matrix, okay, and by the determinant also. Okay, there will be two parts. If you can check by determinant, I will mention that. Okay, now how do we determine it? Okay, it looks a bit complicated, but it's not, as long as you understand what it means. Okay, now and a system of linear equation has, number one, a unique solution if the rank of A is equal to the rank of AB. It's in the matrix, yeah, okay, which is equal to the number of unknowns, which is equal to the number of solutions. The number of columns. Okay. Number two, many solution if the rank of A is less than the rank of AB. Less. Not one the less. Equal, but less than number of unknowns. Number of unknowns is number of columns of A. It has to be equal, but less than the number of columns. If they are not equal, then there is no solution. Okay. Okay. Now let me write out an example. I don't give you the original, but I want to give you the row reduced one. This one, number one, I have shown you before. Yeah, So the rank of A is this side. I close this. The rank of A is 2, right? 1, 2. The rank of AB is the same, 1, 2. Also 2. And the number of column of A is 2. Because there is XY. This is the number of unknowns. So in this case, it's unique. You can say X is 2, Y is 3. If it's not row reduced echelon form, suppose I have a 10 here, right? It's still row echelon form, right? Even if it's a 10, so you close, the rank is 2, the rank is 2, the column is. Okay. For number 2, example will be 1, 2, 0, 0, 0, 3. Okay. This is X, this is Y. Okay, what is the rank of A? The rank of A is, somebody give me the answer. Unmute. What is the rank? Eugene, hari ni saya tak blacklist, tak block. 1 ya? The rank is 1. The rank is how many non-zero rows? Okay, how many non-zero rows? What is the rank?
1.
Ramai-ramai jawab pun tak apa. I want to hear your voice.
1.
Okay, if I open this, what is the rank of the whole matrix? Still 1.
1.
Yeah. Tengok terus ya. Because this is... Okay, so later on we will see how we can write the solution. Now it's determined only. So there is many solution for this. Macam tadi itulah yang overlap, right? Okay. The third one is like this. Like this. What do you see? What is the rank of A? 1, yeah? The rank of A is 1. What is the rank of B? Is 2, right? Because there is a 1 here. 1, 2. So this is 1, but this is 2. So it's less, it's not equal. The problem is when you read through, you get X plus 2Y is 3, but 0 equals 1, right? That is why there is no solution. This is how you determine using the rank. The question might give you, determine whether there is a solution or not. Okay, so there has to be a reasoning. If the question using the rank, show the rank, something with the rank, you have to use this. Okay. Now, let's see. Okay. I'm not going to do all the row echelon. I will just show you and explain from the one given until the row reduce. Yeah. In the middle, I'm sure you can do the row reduction. Okay. Oh, saya cakap tak tadi saya bagi bonus markah for the selfie? Okay. Satu markah bonus. Out of the quizzes. Okay. Okay, the first one is unique by determinant. I have done that. Okay. Then number 1A, 1B. Also unique. Unique, I've done that. C, part C. Okay. I don't give the original, but this is the matrix. Okay, this is already row echelon. So you go to each row, find the first number and circle if it's 1. That is the leading one, yeah? Okay. And you see underneath they're all 0 and then it goes to the right, right? So this is in row echelon matrix. Okay. What is the dimension of this matrix? What is the dimension of this matrix? 1, 2, 3, 4, 5 times 3, right? A is 5 times 3. So there's 3 unknowns. There's 3. Maybe X, Y, Z, right? We have extra equation. It's not 3 by 3. We have extra, but it's okay. If you look at the rank, what is the rank of A? This part. The rank of A, close this. The rank of A is 1, 2, 3, right? Which is actually equal to the rank of AB. 1, 2, 3. Which is equal to the number of unknowns or the columns of A, which is 1, 2, 3. X, Y, Z. So the solution or the answer is unique. It's unique. You think that is too much, they're more than enough, but it can be unique because the one extras, they probably just a multiple of the others or a combination of the others. Okay, although it's there, but does not add up to anything. So the answer is still unique. From here, you cannot solve right away. You can go into row reduce and get the answer. So the answer is -4, 4, -1 is in the notes, yeah? Okay, now let's try. So this is all unique. If m is less than n, so I have given you m is n, m is bigger than n. If m is less than n, you can never get a unique solution. You can never get a unique solution. Yeah, remember this. For unique, it has to be equal or bigger than. You cannot find a unique solution if m is less than n. If m is less than n, you will get many solutions or no solution. Okay, I will give you the example for that when m is less than n. Okay. Okay, let's move on to the second one, which is many solution. Okay. Many solution. That is all unique solution. Eh? Second one is many solution. This is very important to understand how to write the answer, because you will be using this until chapter 5. Okay, and how to write out the answer will contribute to the very last question in your final, which is chapter 5. Okay, how to write the answer. Okay, so for the first one, call it A, the original one. I've done this before, right? Okay, I've drawn this on XY axis, right? It's the same line, yeah? So there's many solutions. We have also see the determinant is 0, so you cannot use the two methods. And if we want to do, because this is 2 by 2, I will just show you this. Because you can just do one time, right? This is already 1. Okay, so we need to make this 0. Negative 2 row 1 plus row 2. Okay. So negative 2 row 1 plus 0, negative 2, 0, negative 2, 0. So if you check, actually the determinant is 0, it's not unique. Okay. The rank, if you see here, the rank of A is 1, because only 1 non-zero row. The rank of AB, 1, only 1. So they're equal. And this is less than 2, which is the number of variables, right? The number of variables are 2, which is the column of A, less than that. So we know there's many solutions. But that is not the solution. That is just many solutions. Akmal Ridwan, macam ada hantu di situ. Tutup kamera tapi nampak macam scary. Okay, so X and Y, write out. Yeah, write out the answer. So X plus Y is 1. Okay, how do you write this? You don't write 0 equals 0. Maybe before you write 0 equals 0, but in this class, what we write is you circle the leading one. Okay, the leading one that you circle is the variable that is not free. Okay, not free. The column that you don't circle, that does not have a leading one, is the free variable, what we call a free variable. Y is free, which means it can take any number, any form. Okay, so Y is K, K in R. This is very important for you to understand. It does not mean that the first one is the fixed one, the second one is the free one. No, it depends on which column that you circle for the leading one. After this, I will show you that probably X is the free one. Okay, so what's the answer? So when Y is K, X is 1 minus Y, which is 1 minus K. Yeah, because Y is free, there is no leading one. So x, you don't put the arrow, is still okay, is equal to x. This is the xy. When I put this, that means here. Or you can just put xy equal like this. Okay, so x is 1 minus k and k. And don't forget to put k in R. Yeah, because k can take anything. Now, Shu Hui, I want to ask you a question. Go Shu Hui. Okay, give me one answer. Give any value to k and then give me one answer for the vector.
1.
Hmm?
1.
It has to be a pair, xy.
0 and 1.
0 and 1. Okay, 0 and 1. When k is 1, because k can be anything, right? When k is 1, 0, 1. How do you know 0, 1 is a solution? You can plug in here, right? 0 plus 1 is 1. 0 plus 2 is 2. Thank you. Siti Nur Auni. Ada ke? Macam tadi ternampak ke? Saya. Ada, betul. Can you give another solution? What do you want the k to be?
2.
2. So if k is 2, you get the answer? Tak dengar je. Bisik ke apa ni?
Negative 1.
Negative 1, 2. Right? Negative 1, 2.
2.
So when you plug in, negative 1 plus 2 is, 1. Negative 1, negative 2 plus 4, 2, right? When k is 2. Okay, so that is why we said many solutions. Because you can give any number. K can be square root 2. Real number. Yeah, if you put square root 2, that will be 1 minus square root 2 and square root 2. 1 minus square root 2 plus square root 2 is 1. So any real number. Even if you want to put fraction. Even if you want to put like 0.3. Okay, how many real number that we have? Infinite, right? So this infinitely many, you can put in here, you can get the solution. That's why we call it many solution. Infinitely many solution. Okay. Probably the question asks you to give 3, right? So just plug in any k value, then you get the xy. Okay. 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 Yang tak okay, you raise hand. Then I see raise hand. Nanti saya ulang balik. Okay, ada pula yang tunjuk apa ni? Tu silap tu, itu bukan ni, itu muscle. Macam. Okay, yeah. So this is many solution for this particular one. So how do you do? It's free. Okay. Another one. Another example. Dah lebih 1 jam. Sebab tadi ada apa ni? Sesi awal-awal. Okay. We take a break and then I give you the second example. Yeah. So it's 9:04, 9:15. Yeah. We come back 9:15. I'll just give you the final form, yeah. 1 0 2 2 0 1 3 3 0 0 0 0. So you see, if you have a row of zeros, ada ke tidak ni? Tak nampak. Orang langsung pun. Let me wait a bit. Okay. Cakap dengan skrin seorang-seorang. Baik, saya rakam aja kan. Then you can just look anytime. Okay. That's much better. Barulah bercakap dengan kelas. Okay. So, don't assume if there is a row of zeros, then it's many solutions. Because I've given you earlier, you have 2 zeros, right? 2 rows of zeros, but the answer is unique. So don't assume, okay, there's a row of zeros, many solutions. Tak betul lah. So you have to look at the rank. Yeah. Okay, so for this one, the rank of A, 2, yeah. The rank of A, B, 1, also 2. Right? So it's equal, but less than 3, which is the number of variables. Okay, so many solutions. Okay. Then, how do you write the solution? Okay. Can you imagine if you fail to reduce to the right row echelon form, then all your answers will be wrong. That's why the row echelon form is very crucial and the elementary row operation. Okay, so we write. Suppose the variables x, y, z. Okay. So we put x plus, there is no y, x plus 2z is 2, y plus 3z is 3. And then circle the 1, 1. So the column that we circle the 1 is the one that is not free. Yeah. So x is not free, y is not free, z is free. So when z is free, we put like this. A free variable. If you don't put the variable free, it's okay. As long as you put z is k. Okay, if you want to put z is free, also okay. The important part is to put z in terms of k. Okay, then we write the solution. So x, y, z equal, so this is 2 minus 2z, right? So 2 minus 2k, 3 minus 3k, and then k. If you fail to put a k in R, minus 1. Because k can be any real. Okay, we strictly put our matrix for real and not complex for chapter 2. Okay. Now, you can give, if k is 0, you will get 230, right? If k is 0, 230, then you can check your answer. It's good to check back, plug in the original question and see whether it's right or not. I didn't give you the original question, but in the real exercise you will get, or you can just put here, 230, 230, 2 plus 0 plus 0 is 2, yeah. 230. 3 plus 0 is 3, yeah. Okay. The third one. One, two, three, four, 1, 0, 0, 1, 2, 2, 0, 0, 0, 1, 3. Okay, and then you do to the row reduce, yeah? 1, 2, 0, 0. I skipped the step, but you have to do it. 0, 0, 1, 0, negative 4. 0, 0, 0, 1, 3. Okay, so this is 3 by 4. 3 by 4. Definitely cannot get unique. Yeah, it's less. So maybe no solution, maybe many solution. Okay, so we want to see which one is free. Go to the first row and see the first number that you see. It has to be 1. That's the leading one for the first row. Okay, go to the second row and circle the first leading one. Go to the third row, circle the leading one. Then you determine which column. It's X, Y, Z, W. Don't ask me why it's not W, X, Y, Z, because they want to start with X maybe. X, Y, Z, W. So if you want to check the rank of A is 3. The rank of AB is also 3. And the row, the column is 4. So many solution. Yeah, because it's equal, but it's less than the number of variable. So many solution. Now, how do you write the answer? So you will write X plus 2y equal 1. X plus 2y equal 1. That's why I put this on top, so you can match. This one is Z. That's why I put a space here. Z equal negative 4. And then W equals 3. That is from the final RREM, is row reduce. Row reduce because there is 1, this is 0. Okay, then you go to second one, this is the 1, this is 0. And you go to the third one, this is 1, this is 0. It's okay that this is not 0 because there is no leading 1 in that column. Yeah, somebody asked me from chapter 1 earlier, it's okay. So it doesn't matter, it doesn't mean that it has to be all 0 all over. If there is that 1, top and bottom has to be 0. This one, no, because Y is free, right? X is not free, Z is not free, W is not free because there is a leading 1, but Y is free. Y is free. So Y is K, the free variable. Then we can write X, Y, Z, W equal 1 minus 2K because Y is free. X, Y is K. Z is negative 4. W is 3. Somebody asked me, Why you use K but your notes use C? You can use any letter but not X, Y, Z, W, right? Because it's already taken. So I used to use K. You can put any. This one I use C. So that is a note there. The leading one, which is circle, is not free. So the one with no leading one give the free variable. Yeah, I explained that in the notes. Okay. Now, you see in my notes, I write like this. I take out the K. I take out the K. So you have -2, 1. There is no K. Plus, and then I take out the number, yeah? 1, 0, -4, 3. Okay. If you check back, it's the same. -2K plus 1, K, -4. Why? Because you will need to know how to write this in chapter 3. So that's why I give this another alternative to write the answer, so you get used to it here in chapter 2. But this is already the right answer. Okay, if you don't write like this, it's okay. But in the notes, if you see why I write like this, because this is what we have to write in chapter 3 later. Yeah, to separate the one that multiplied by the free variable with another vector. Okay. 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 Okay, now the third one is no solution. Third one. Okay. So no solution if the rank of A is less than rank of A, B. Okay. The first question is the one that I gave before. 1, 1, 0, 0, 1, 1. Yeah. So when you want to write out, if you don't do the rank, you will write like this. 0 equals 1 is false, so no solution. That is one way to write. You can also write rank of A is 1, rank of AB 1, 2. Right? So rank of A is less than rank of AB, thus no solution. This is, if the question said determine the solution using rank of the matrix, then you had to show using this way. Otherwise, you just write this. 0 is not 1, it's also okay. If the question did not specifically say that you had to use the rank. Okay. Another one. 1, 0, 2, 2, 0, 1, 3, 3, 0, 0, 0, 10. It's quite easy, right, for no solution, because you will see always there is a row or 0 equals something else, right? So this one, rank of A is 2, rank of AB is 3. So no solution. Okay. The hard part may be to do row reducing. You can have M bigger than N, M bigger than N, and no solution. Just now we see M bigger than N and unique. n bigger and n can give unique, no solution, or many solution. All is possible for m bigger than n. Okay. So I give you one example. This is not the original, but the row reduce. You see, there is 0 equal 82, right? So easy to say there. But if you want to use the rank of A is 1, 2, 3, 3 non-zero rows, and the rank of all is 4. Okay, so this is it. Okay. I will pick some other exercise, maybe from exercise we can try. But there is also one exercise that I give in the e-learning. Sometimes you are given something different. Okay. This is actually an example, not example, a question from a final exam, like not long time ago, past final. This is past final exam question. Okay, you are given this. Okay, you are given this augmented matrix of a system of linear equation, which has been reduced to upper triangular form. Okay, to upper triangular form. Determine the value of A and B. So the solution is unique. Unique, many, okay. Any suggestion? So to determine the value of solution is unique. You know, unique means we want the rank of A has to be equal the rank of AB equal 3. Okay. We want the rank of A. You don't have to look. You don't have to write. Focus. Focus, focus, focus. Write later is there, but I will give you time to copy. Focus. Okay. For it to be unique, okay, then you look at the augmented matrix. right? You have 3 column X, Y, Z, right? X, Y, Z. So you can write X, Y, Z. So you know that there are 3 variables. For it to be unique, you want the rank of A to be equal to the rank of AB equals 3. Okay, you want the rank of A to be 3. How do you want to get 3? B squared minus 4 doesn't need to be 1. Later on, we want it to be 1, right? But as long as it is not 0, right? So rank of A will be 3 if B squared minus 4 is not 0. If it is 0, if this is 0, then the rank would be 2, right? Automatically. Why I don't say equals to 1? Because it can be anything other than 1. If this is like 10, you can reduce again, right? Divide by 10, then you get 1. So this is not 0. How can you get the rank of AB to be also 3? Once this is not 0, it doesn't matter if this is 0 or not. Doesn't matter anymore, right? Because if this is not 0, the rank of A and B is also 3. So A minus 2 can be any number. Okay, so it's a little bit abstract, but you have to think and putting in probably some numbers in your mind. Maybe this is 10, maybe this can be anything like 12, 20, whatever. So your answer will be B squared is not 4, which is B is not plus minus 2. And A is in R. That is the answer. Okay, didn't ask you for a specific A or B, but as long as B is not plus or minus 2, and A can be anything. What happens if B is 2? Then you can try and check. If B is 2, you will get 0 here. Okay, and this one can be anything. If B is negative 2 because you square, this will also be 0. You cannot get it unique. So this is the answer for the first part. Just leave it there. B is not plus or minus 2. A is in R. Okay. Nasib baik Farhan is on video. Kalau tidak dia gini. Siapa yang nampak? Okay. So for the many one, right, it's very similar. But for the many one, row of A is equal, right? A row of AB, but we want it to be less than 3. Right? We want it to be less than 3. Is it possible? Is it possible? Okay. You see, from this one, the row at the rank has to be bigger or equal to 2, right? Because there is already 1 here, 1 here. So the rank is at least 2. So you get already 1 here, 1 here. So the rank is at least 2. So we cannot have 1. At least 2, meaning it has to be 2, right? Okay, because we want it to be less than 3. Okay, to be 2, this one has to be 0. Right? This one has to be 0. So the rank is 2. And this one has to be 0. So A minus 2 is also 0. So you will get 0 rows, right? And then we get many. So this will give us B is plus or minus 2. A is 2. Then you can check and put in the values in the original. When B is plus or minus 2, this is 0. When A is 2, this is 0. So this will be the answer for the many solution. Okay. Okay, okay. Ni wakil ni, Farhanis. Begini aja dah, okay. Okay. For the no solution, we want it to be 0 and not 0, right? It doesn't have to be a number at the end, as long as it is not 0. So this, we want it 0, this one to be not 0. So the rank is less. So the rank has to be 2, this rank has to be 3 actually. So the rank of A has to be 2, which is less than the rank of AB. We want it to be, it doesn't matter, right? You just put like this. As long as the rank is less, and we know that this is bigger or equal to 2. Because of this 2 already, we want to be less, and the most that we can get, because there are 3 rows, is 3. So you don't need to worry and write this, but just come up with if b squared minus 4 equals 0, and a minus 2 cannot be 0. Okay, cannot be 0. So you have 0, not 0. This will give b is plus minus 2, a is not 2. Thanks. So that is the answer of this 3. Okay, it's quite complicated. That's why it's in the final exam. In your quiz, it's only 15 minutes for 2 questions. Yeah, okay. That's another final exam question that I put in the notes. So this year I had to change it. All right, so for this one, before I erase, any question? Anything that you want me to explain? Why? Why is it equal to? Why is not equal to? It's clear, right? Once you understand the rank, then whatever is given to you, don't just jump to the final conclusion that you have to get it equal to 1. Because even if it's not 1, even if it's like 20, you can also reduce again, right? As long as it is not 0. Okay. Okay, and there's another one. 2, 1, negative 1, 0. 1, A, 3, 2. 2, 1, 1, 4. The question is, find the values of A where the system is consistent. You know, you cannot use determinant because if m is n, you can find determinant, right? And determinant is not 0, then we have unique, right? Then you can use all method. But if A is 0, you can have either many solution or no solution. If it's many solution, it's consistent. If it's no solution, it's not consistent. So if you find the determinant, you want to let determinant is 0 and then you set for consistent, no. Cannot use determinant. You can only mention about not unique if this is not 0. But the question is consistent. And consistent involve unique and many. Okay, so for this particular one, you cannot use determinant. All right. Okay, so we have to use the row operation, Gauss or Yeah, the elimination. Reduce Gauss Jordan. Yeah. Okay. Now there is an A. There is an A. We don't know whether A is 0 or not. Okay, so avoid dividing by A because we don't know what A is. So what I will do is I erase the question. Yeah. For I put here for consistent. Because I want to put here. Okay, so you want to get the first column and the first row to be 0. So row 1, row 2. Okay, 1, A, 3, 2, 2, 1, negative 1, 0, 2, 1, 1, 4. Just switch. All right. Now we already get the first one. No need to copy because it's in the notes, yeah? Just look at the process. Okay. This you want to be 0. This you want to be 0. Okay. So negative 2 row 1 plus row 2, negative 2 row 1 plus row 3. Okay. 1, A, 3, 2. You see when A is involved, it's not a number. How you will deal with this? Negative 2 plus negative 2 times 1 plus 2 is 0. Negative 2A plus 1. Okay, just leave it. Negative 6 plus negative 1. Yeah. Negative 4 plus. Okay. Then negative 2 R1 plus R3. The same. Negative 2, negative 6 plus negative 5. 0. Okay. Now, how do you solve this? As I said earlier, we don't know what A is. So don't divide by anything. But we need to make this 0, right? They're the same. So you can just do negative row 2 plus row 3. Because they are the same. Okay. So 1, A, 3, 2, 0, negative 2A plus 1, negative 7, negative 4, 0, 0 is the same thing. So negative of that add, right? And 7 is 2, 4. Okay. Then I want to reduce one more to make this a little bit nice. But I will cheat. I will cheat. I will cheat. Jangan marah, eh? Understand? Safe tempat. Okay. Now, you look at this. Okay. To be consistent, okay, if this is not 0, if this is not 0, then we get the rank is 3, right? If this is not 0, like a number, if this is a number, the determinant is just that, right? So this cannot be 0, then we get unique, right? Unique. If this is not 0, it will be unique. Okay. What happens if this is 0? then you have to see. Okay, if it is not 0, then we get A is 2A is 1, A is not. Okay. If A is not a half, then you will get a number here. Like maybe A is 4, say A is -2, A is -2, not half, A is -2, you'll get 5. If you get this 5, you can reduce, right? Until you get 1. And then all the determinant becomes not 0. What happened is A is half. I don't know what happened because I have to see what happened if this is 0. Do we get 0 later on equal 0? Or we get 0 equal number? Then you have to do more work. Okay? So what we have to do is when A is a half. Okay? If -2A plus 1 equals 0, that is A is a half. Yeah? Then we try to see what happened to the matrix. Okay. So I will get, if this is 0, right? If this is 0, so if A is a half, we get 1, 1/2, 3, 2. 0, 0. Just now we want it to be 0. -7, -4, 0, 0, 1, 2. Okay, and you need to reduce. We need to reduce. You see, this is not a multiple of this. So it won't be all rows of 0. So I will suspect that there is no solution for this one. Because if it's many solution, it's still consistent. So the A can be any number, yeah? If there is a row of zeros, many solution means consistent. So at the end, A can be any number. It's not equal to half, it's equal to half. But let's see. I will erase. One more, yeah? Row 3 and row 2. And lastly, I just do down, yeah? I don't do top. 7 row 2 plus row 3. $14, 10, right? Okay, so this means no solution. Whether you put 0 equals 10 or the rank is less. The rank is 2, the rank is 3. So for this one, there is no solution, but don't forget to answer the question. Thus, for the system of linear equation to be consistent, A is not a half. That is the final answer. Don't forget to answer the question. If you just give this and you don't check this, okay, what happens if there is a row of 0 here? It becomes many. That's why you also have to show, in this case, there is no solution. So you take just this case. Okay. It's quite long. That's why it's in the final exam. Okay, so I give you lots and lots more example. Make sure you, because in the one that uploaded in the e-learning. There's blank spaces for you to test yourself and do the exercise. Try that first. And then if you get stuck, you go to the full notes, yeah? Because in the full notes, there's the answer there in the beginning. Okay. I want to show just one more before we go. Shihang or Hannah, can you help me to share the tree of system of linear equation? This is to finish up this chapter. On Tuesday, I will go through the exercises and any question for chapter 2, and then give you your quiz. Yeah, and then we start with chapter 3. Okay, so this is how I summarize. Yeah, this is how I summarize chapter 2. Okay, so for the system of linear equation, yeah, with m equation and n unknowns in general, right? I separate into 2. I separate into ax equals 0, that is homogeneous, and the non-homogeneous one, the one that we do today, is ax equals b. Okay, as I mentioned, for the homogeneous one, it is always consistent. It is always consistent. All right, we will use this a lot in the next chapter. Okay, until chapter 5. It's always consistent. But we have 2 cases. Okay, probably they are equal. Okay, and they are not equal, meaning it's not a square. Okay, it's not a square. For the one with the square, we can find the determinant, right? So when the determinant is not equal to 0, then the solution is unique. Okay, for this column here, you see, when the case m equals n, every time you see the determinant is not 0, you will always see a unique solution. Okay, this is when m equals n. Yeah. So m equals n, determinant is not 0, you will always get a unique solution. Okay, so we go back to the homogeneous. It's always consistent. But what happens if A is 0? Yeah. So when the A is 0, you know, we have to always have solution. The one left will be many. So in conclusion, when it's homogeneous, right? When it's equal, you can only get these 2, unique or many. For the case homogeneous and m is not equal, it can be less or it can be more. If it is less, always many. Yeah, if it's less, always many. But I show you earlier today, if it's more, it can be also unique or many. Okay, the unique one that I didn't mention, if this homogeneous is equal to 0, yeah, unique means, what does it mean by unique? Unique means it's always 0 solution, 0, 0, 0, 0. So when you get ax equals 0, and when you know this is unique, it means x is the 0 vector. That's unique. Okay. So now we go to the case in which we have the non-homogeneous meaning there is a B here, yeah. So when the case M is N, still we get the square. So there is a case where the determinant is not 0, unique. That is really straightforward. In the case the determinant is 0, yeah, there can be many or no solution. The only thing we don't know is, we know is it's not unique. You don't have to memorize everything. Just I want to share that there are many possibilities. And the way to get the answer is by solving it. Yeah. This is showing that you cannot just jump into conclusion. You can refer to this for the type of solution. And lastly, when for the non-homogeneous, when there is not a square, it can be less or it can be more, the number of row. Yeah. If it is less, then you have two types. Can be many or no solution. There is no possibility of unique, okay, because the determinant cannot be determined from here, and it's M is less than N, for sure you cannot get this unique. But the last one is the most dangerous one. Okay, this is the case AX is B, is not a square matrix, and M is bigger than N. M is bigger than N, then you can have all possibilities. And the next page is an example to show all these to show all these 13 cases. So what you have to do after today, okay, is to try and solve each one of these. Where is number 13? Oh, this one has no, okay, you need to add. You can add Shiham. I think in the, I think we already added, right? Number 13.
This one is from the books.
Oh, this is from the book. Okay, okay, okay. Okay. Can you please add? Because once I printed, I just realized number 13 is missing. So number 13 is the one that in the e-learning, X plus Y is 1. Maybe you can write, Sham. X plus Y is 1. It's like number 12. X plus Y is 2. Wait, that number, wait, Sham. Can you undo that? Plus Y is 2. Okay, that is number 13. That is number 13, Sham. Okay, number 12 is missing. Number 12 is X plus Y is 1. 2X plus 2Y is 2, is a double. 2X plus 2Y is 2, and 3X plus 3Y is 3. Because I want it to be many solution. Yeah, because it's just one line, right? Just one line, and then the rest is just on top of that. Number 13 is the difference or no solution for that one. Okay, so your task is you can use any method, but solve this and match this with the 3. You know the solution. So that is your task for, if you cannot finish by this Tuesday, if you can finish, we will share. It's not that long, right? Just do it. Okay, so by this Tuesday, then I will ask anyone to share the answer.